Hi, in this video we're going to continue looking at truth values and we're going to jump straight into the code. So first things first, we saw that we can call the bool constructor with, let's say, a value of 1 and we get a true value back. We can call it with a value of 0 and we get a false value back. In fact, we can call bool with any integer in there, maybe -1, and that will also return true. So be careful, by the way, here. In some other languages, -1 is sometimes used to indicate a false, not so in Python. The only integer value that really is false is 0. Everything else that is non-zero will be true. So even bool of -1 or even bool of 100, all that returns true. What's happening here is not that we are converting that integer to a Boolean. What's happening instead is that special method that we discussed called dunder bool, dunder. And that is a special method that gets called. When we call bool of x, what's happening is that Python is looking for at this variable x, this parameter x, which is an object, and it's looking for an instance method called dunder bool. If it finds it, it runs it and then puts that as the return value. If it doesn't find it, it tries to look for the dunder len method and it will return whatever that value is. So if that value, let's say it's 0 for a sequence of length 0, it will return 0. Then we'll get 0 back, and 0 has a truthiness of false. It is falsy. And if there are elements in the sequence, then of course the length is going to be greater than 0. It's going to be a non-zero number, in which case the truthiness will be true, will be truthy. So let's take a look. We can actually see this when we look at the help in the console. So we can look at help on int. And if we scroll down a little bit, you'll see that we have this dunder method defined. So int defines this method right here. And all it does, it just returns the instance value, that's self, not equal to 0. So it runs this test, this comparison test. So when we did bool 100, it really just ran this. It executed this statement and returned that. And that's the same thing that happened when we did bool 100. We got that. When we called bool 0, okay, which remember was that, all we did was really just evaluate this expression. And we got false. So in fact, what's happening when you call bool 100, what Python is actually doing, it's taking 100, and I got to put parentheses around it, but it's the integer 100, and then we're going to call the bool method with that special dunder before and after it. And we can see it's the same thing. If we did bool of 0, that's the same thing as calling 0 dunder bool. And we get false in both cases. So that's really what's happening. And all the objects in Python will implement this bool method or this len method, or potentially neither of the two, in which case the object will always be truthy. But for example, we can look at a list. And if we look at the list, we'll see that we'll find, now there is no bool method, but there is a len method. There we go. And the len method returns the length of the sequence. And this is why the truth value of a sequence is 0 only, or is false only when the length is 0. Because 0 has a false truth value, right? We saw that bool of 0 is false, right? So if we have a list like a equals, let's say, an empty list. When we call bool of a, what we're really doing here is we're calling a, well, let's do a, well, no, I don't need the parentheses here, a dunder len dunder, which is returning 0. And bool of 0 is false, right? So in fact, we're getting bool. So when we say bool of a, which returns false, what's really going on is we're looking at bool of a dunder len. Okay? So behind the scenes, that's what's happening, and that's how we're getting these true and false values that are associated with all objects. If an object doesn't have the bool method and doesn't have the len method, then it will always just be true. Okay, so let's look at the numeric types. So if we look at numeric types, we saw that for integers, but it really works the same for any numeric type. So I can take a float like 0.0. We can look at a complex number, 0 plus 0j, for example, and we'll get false in both cases. Same thing if we want to work with, let's say, the decimal class, and maybe we'll from decimal import decimal, and let's even do this with fractions. So from fractions import fraction. Let's import those two classes, and let's do bool of fraction. Now we want a 0 fractions. I'll put 0 in the numerator, but of course we can't put 0 in the denominator. That would give us a problem, but 0 over 1 is 0, so we'll look at that. And we'll also look at the bool of decimal, and we'll make the decimal 0. So when we do that, we get false again in both cases. And this will work the same for any numeric type. If it's a non-zero value, it will always be true. So we could say bool of, let's say, 10.5. We could say bool of 1j, that will be a complex number. We can say bool of fraction 1, 2, and maybe bool of decimal 10.5. Okay, so if we do that, then we'll get that the corresponding truth values are all true. So that's how it works for numbers, for the numeric types. Next, we can look at the sequence types. And remember, the rule is that every object, so every sequence, will be true, right? Will have a true truth value unless the sequence is empty, has nothing in it. So for example, we can take A equal to an empty list. We can set B to maybe an empty string, right? And maybe C to an empty tuple. So now if we look at bool of A, bool of B, and bool of C, we get false in all cases because they have no elements in them. On the other hand, if we populate that, and let's put a few characters in the string, and let's put maybe this tuple this way. So now our sequences have elements in them, so the length will be non-zero, and in that case, they turned out to have a truth value of true. So that's how it works for sequences. Now mapping types are the same. Mapping types, you can have a dictionary. Let's do an empty dictionary that we can define this way, or if you prefer, you can also just use the constructor, whichever. I'm going to use the literal, and we can do a set. Now a set, technically this would be a set, right? This is a set, and we cannot use the literal constructor this way. That would construct a dictionary. So instead here we do have to use the constructor to create an empty set. So in both cases we have an empty mapping type. As you can see here, the A is just an empty dictionary and B is an empty set. And if we look at bool of A and bool of B, well, they're both falsy, right? But if we populate values into that, let's say we have single key value pair in there, and maybe we put a couple of elements in the set, in which case, by the way, you can write it now this way. Python is able to differentiate that this is a set as opposed to this, which is a dictionary, because of the colon here. And we'll see dictionaries and sets in a lot more detail in an upcoming section in this course. So now we can see they have values in it, and their truth values are true. So they're both truthy because they have elements in them. Now the none object is special, and it always just evaluates to false. And that's pretty interesting because this allows you to use it in if statements. Now, the way it works is that when you have a Boolean expression in Python, you can actually put, instead of Boolean values, you can put objects in there. And what will happen is that Python will detect that and will realize that, wait a minute, I was expecting a Boolean value here, right? So what am I going to do? Well, it's actually going to look at the associated truth value instead. So that's why this works in an if statement. So for example, let's say we do this. A equals, so this is one application of all this. let's say we have a sequence. We have A, which is a sequence, it's a list in this case, and we want to do something with this variable A, but only if it exists and if it's non-empty. So one way to write this would be to say if A is not none and the length of A is greater than 0, right? We're explicitly saying what we want. And maybe I will print the first element of that sequence. Otherwise, I will print nothing to see here, okay? And when we execute this, well, it passed the test. A is not none, because A is, this thing here. And A has a length greater than 0. It has 3 elements in it. But we can write this in a different way. We can say if A, and then I'm just going to copy the rest right here. And this will work exactly the same way. Why? Well, the first thing, if A, well, it's looking at essentially this, right? That's the first step that it takes. But Python will do that implicitly for us. We don't have to put this bool in front. So it's going to look at the truthiness of A. It's going to look at the associated truth value. Now, A is not none. So that is true, right? The truthiness of A, as long as A is not none, is true. Furthermore, the length of A is greater than 0. So it's going to say, oh, okay, well, the length of A is greater than 0, so I'm getting again a truth value back. If A was none, I would get false here. And if A was not none, but the length was equal to 0, I would also get a false, since 0 evaluates to false. So if we do this, if we say A is equal to the empty list, then we'll get nothing to see here. If we put A equal to none, we'll get the same result, nothing to see here. So basically this, and of course we don't even have to put bool in front. Let's just check, as you can see. So this statement here, in this case, is equivalent to this statement here. So it's just a little more concise, but it does precisely what we expect it to do. Now, if you do write things over here this way, which you certainly can, you've got to be also a little careful. Because if you were to write it this way, we could also run into some trouble. Let's say that A equals 1, 2. All right, so that's fine. That works. Let's say that A is empty. Well, that works as well, right? But let's say that A is equal to none. Then what's going to happen here is that it's going to calculate first the length of A and see if it's greater than 0. Well, A is none. The none object doesn't have a len method, a done-the-len method. So this is going to fail. So when we run this, as you can see, we get this. The none type has no len function defined. So again, so if you do write it out, you certainly can. And we'll take a look at this. It's called short-circuiting. Why didn't it fail here? If A is not none, and what happened, and we'll look at that in much more detail later, but what's happening here is that A is none. So this is coming back false. And so it doesn't have to even evaluate this piece here. And that's why this runs without any problems. It doesn't fail. Whereas this one, when we had len A in front, did. So just a minor thing that I wanted to point out that you should be careful with. All right, I think that's really all there is to say about the truthiness of objects. They all have, an associated truth value, and it can be put to really good use. Things like this you might want to use, let's say if you're connecting to a database and you're getting a field back from the, from a table that is a string and maybe it's a nullable field. So you can get one of 3 situations. You could get a null value back, which would be none. You might get an empty string back, which would be a list, essentially a string that exists, but it's empty. It just doesn't have any characters in it. Or you might actually get characters. And you may want to only handle the field if it's both not null and not empty. That's something that's very frequent when you're working with text fields in databases. So that's a good use of it there. All right, thanks for watching, and I'll see you in the next video.